Hi, welcome to my video on graphing polynomial function given points f prime, first derivative, which is slope of the tangent, and f double prime, which is concavity, upward or downward. Graph each polynomial. F of x is linear, and the f of 1 is 3, and f prime of x is 2. So f1 of 3, x is 1, y is 3, because the ordered pair is x, f of x, which is the same as x comma y. So f of x is the y. And f prime is the derivative, so the derivative, because it's linear, the derivative is the slope, so the slope is 2, because f prime is the derivative. So that means we have a point of 1, 3, which is right here, and its slope is 2 over 1, so we rise 2, 1, 2, and run 1, or we can go down 2, left 1. So there's the line that represents this info. Another way to do it would be to take the slope as 2. This is x, y. Slope is 2, and write y equals mx plus b, which is the equation for a linear, provided it is not vertical. And we have y is 3, m is 2, x is 1, so we solve it for b. So 3 equals 2 plus b. So b equals 3 minus 2, 1. So y equals mx plus b. Slope is 2, and the y-intercept is 1. So if you got the equation, the y-intercept is 1, which is right here, and the slope is 2 over 1, so you rise 2 and run 1, rise 2, run 1. So the easiest way is to plot the point and do the slope, and you don't need the equation, but I did both. Number 2, f of x is a quadratic. Quadratic, which is a polynomial, is a parabola. So we have the f of 3 and the f of negative 1 is 0. So that means when x is 3, y is 0. When x is negative 1, y is 0. And y is 0 on the x-axis. So therefore 3 and negative 1 are the x-intercepts. So 3 zeros here, negative 1 zeros here. So these are the x-intercepts. And it says we have f of 1 equals 2. And so the f of 1 is 2. So that's the point. That's the point 1 comma 2. So there's the point 1 comma 2. X is 1, y is 2. And it says f prime of 1 is 0. So that means at 1, the slope of the tangent is 0. So at 1, and 1 is this point right here, 1, 2. So that means this is the vertex of the parabola, because if f1 is 0, the slope of the tangent is 0 right here. So that means this point is the x-coordinate of the vertex, where the slope is 0. So there's the vertex coming down through the intercept of negative 1, coming down through the x-intercept of 3. Again, that's the vertex given by, because that's 1, and the slope is 0 at 1. This point is 1, 2, so this is the vertex of the parabola. Number 3, f of x is cubic. And again, we have f of negative 2, f of 0, and f of 4 is 0. F prime of 2 is 0. The f prime of x is less than 0 when x is greater than 2. And f double prime of x is greater than 0 when x is less than 1. Let's see what all this info is. So let's plot. So this is negative 2, 0. So that's an intercept at negative 2. And we got 0, 0. So that's an x-intercept at 0, x-intercept at 4. So these are the x-intercepts. So cubic is passing through here. So we got the cubic, and we got 3 x-intercepts. So it's either coming down here and looping like that, up through, like that, or it's coming up through like this, and coming down through and doing this. Because it has 3 x-intercept, it has to pass through each of these intercepts. So the f prime of 2 is 0. So that means the derivative at x equals 2 is 0. So at 2, 2 is like anywhere on this vertical line, where x equals 2, the derivative is 0. So the point could be here and get a tangent of 0, or the point could be here with a tangent of 0. So the point is either up here or down here, but it's not here because it's not an intercept, x-intercept. F prime is less than 0. That means the slope is negative when x is greater than 2. So x is 2 here. So when x is greater than 2, the slope is less than 0. The slope is negative. So that means it can't be down here because it was negative. If the point was down here and it was a negative slope, it'd be doing this and it wouldn't go through that intercept. So the point must be somewhere up above the x-axis. So let's put the point right there. And so what happens? It says that when x is greater than 2, the derivative is negative, is less than 0. So that means it must be coming down through here. And again, at 2, greater than 2, at 2 we have a 0. So we have, this is at 2, we have a maximum or minimum point. So it's leaving there, derivative is less, is negative, so it's coming down through like this. So at 2, if that's negative, then it must be positive coming through here. So it bends and comes down through here. It must come down through this intercept, and then down here it curls, and it goes back up. And verify that, what we have, f double prime is positive. That means if f double prime is positive, that means the concavity is positive on the left side of 1. So x equals 1 would be, let's say right here. X is 1 right here on this. It don't make any difference if it's 1, 2 or 1, 1. Makes no difference. X is 1 like right here, whatever this point is. That the double derivative is concavity. Concavity is positive, means it's open upward to the left. So this concavity is opening upward on the left. So if that's on the left, on the right it must be negative. So it's opening downward. So this is the graph that fits that cubic. And number 4. Again, f of x is a cubic, and we have 4, 1 is a minimum point. F prime of x is greater than 0 when x is less than 1. And 2, 5 is an inflection point. That means concavity point. On one side, it's opening upward. On the other side, is opening downward. We'll find out as we do more information. And f double prime of x is less than 0. That means less than 0 at x is less than 2. So if it's less than 0, concavity is negative. That means it opens downward on x is less than 2. Let's have a look. Minimum point, 4, 1, right here. Okay, and we have an inflection point. Let's put that in. X is 2, y is 5. So here's the 2 points. And at 4, 1, it says it's minimum. So that means minimum means it's opening this way. This is the minimum point. So it has to open like this and go out here. And let's see. So we know it's going to curl like this. This is an inflection point. An inflection point means it's negative on one side and positive on the other of this inflection point. Let's look at the slopes of the tangents. When x is less than 1. 1 is right here. When x is less than 1, the slope of the tangent is positive. So 1 is somewhere along here. So if it's here, then it's positive, it goes down this way. If it's here, it goes down this way. So if x is 1, the slope is positive, greater than 0. The slope is positive. And we have double prime is less than 0 when x is less than 2. So when x is less than 2, the concavity is negative. So that means that if this is an inflection point, the concavity is negative. So it means it must go above this and then come down through. So let's see if this is right. And it joins up here. So at this point, notice this is the point where x is 1, but y makes no difference. We know that y is going to be greater than 5. So this point, let's see, if we take x is 1, less than 1, the slope is positive. Perfect. And concavity is when x is less than 2, x is less than 2 here, the concavity is negative, means it opens downward. That means on the other side, it's opening upward. Perfect. And that's in the inflection point. So there's the graph. Number 5 is a little bit different. We have to look at all the conditions here and which graph fits. Which graph fits? F of x is a quartic polynomial. The f of 0 equals 0. The f prime of x is greater than 0 when x is greater than 3. F double prime is greater than 0 when x is greater than 1. And f prime is greater than 0 from negative 3 to a 0. X is in between. So, and f double prime is f double prime is less than 0 when x is greater than negative 1. The double prime is concavity. Double prime is concavity. So here, greater than 0 means it's opening upward. Less than 0 is opening downward. And the single derivative is the slope of the tangent. So let's have a look. Quartics. So 1, 2. So we got 0, 0. But we only have 3 x-intercepts. So this is a cubic. So, nope. So let's see what the conditions are. 0, 0. Perfect. The slope, when x is greater than 3, the slope of the tangent is positive. True. So this condition is met. The double derivative, when x is greater than 1, x is greater than 1, the double derivative is positive, means it's greater than 1. The x is greater than 1, which is right here. The concavity is positive. Nope. The concavity is negative. Nope, don't fit. Again, this is true right here, but this is not true. So again, just have a look at it. The concavity is positive. It means it opens down when x is greater than 1. Greater than 1 is here, is opening up. So it's not this one. C, we have 0, 0. Perfect. Greater than 3. When x is greater than 3, the concavity is positive. That's true. From greater than 3, concavity is positive. Or sorry, not concavity, slope of the tangent is positive. And the double derivative is positive. It's going upward when x is greater than 1. When x is greater than 1, it's going upward. Perfect. And the slope of the tangent between negative 3 and 0. Between negative 3 and 0, the slope of the tangent is greater than positive. No, it's positive here and then it's negative here. So it's not this one. So this must be the answer. Let's see. We have 0, 0. Perfect. The greater than 3, the slope of the tangent is positive. Greater than 3, positive. Perfect. And concavity is positive to the right side of 1. To the right side of 1, concavity is going up, positive. And between negative 3 and 1, the slope of the tangent is positive. Positive, perfect. Between negative 3 and 1, positive. And the double concavity is, double derivative is concavity. It opens, is negative, it opens downward. When x is greater than negative 1. When x is greater than -1, it's opening downward. It's the parabola. So this is the right answer. So that's a review on graphing polynomial functions using the first derivative, second derivative. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.